Thank you again, everyone, for joining us. We appreciate your time and are excited to dive into this topic. I'm Lev Kapoor, technical lead at Bit, and I've been using Bit for over 3 years now. First as a customer and then as part of the Bit team building composable systems. Today, we will explore how to scale edge function development, leveraging the principles of composability and modularity. We believe this is the way forward for achieving accelerated and efficient development. So let's start with the current state of edge functions. Edge functions are the next evolution in serverless computing, designed to mitigate the inherent limitation of traditional serverless due to the notorious cold start problem. Edge functions run near to the source of request. Proximity leads to reduced latency. This, along with the auto-scalability feature of serverless, results in improved performance. And edge functions find their use cases in a wide variety of scenarios. Data processing, because of saving bandwidth by moving the data closer to its source. Glue code, content localization or personalization, since these edge workers get deployed closer to the user, and we can customize the content according to their geolocation itself. As the number of edge functions within a system grows, managing these distributed entities becomes an increasingly complex task. Edge functions, by their very design, encourage the deployment of lightweight, purpose-specific pieces of code. And this modular nature makes it convenient to add new functionalities and deploy as separate functions. So when a project begins, you might have a handful of these functions, and your product grows and evolves, and the number of edge functions can multiply, and leading to a constellation of these small dispersed functions. And next, consider the complex web of dependencies each function may have, including external libraries, SDKs, and other functions. And as your ecosystem edge functions expands, so does the network of dependencies, resulting in this tangled dependency jungle. And without insights into this complex dependency graph, it gets difficult to keep the system and developer experience consistent. And lastly, as the number of edge functions grow, discoverability becomes a challenge. The traditional mono-repo or multi-repo structures fall short. If anything, they make the problem worse, transforming core discoverability into a laborious, time-consuming task, which at the end hampers time to market and innovation. So these challenges, although complex, are an inevitable part of scaling edge function development. And what we need is a system that can help us effectively manage these issues and allow us to leverage all the good part and potentials of these edge functions. At the core of Bit's approach to solving these problems lies the use of a component-based architecture. And this approach perfectly complements the nature of edge functions themselves, focusing on encapsulating specific functionalities into independent, reusable pieces of code. Instead of adding to the chaos of function multiplicity, Bit promotes code reusability, improving development efficiency and speed. Bit also turns the dependency jungle we saw into a well-structured graph. With the Bit's dependency graphs, you can track and manage dependencies at the component level. And lastly, Bit considers your components as a discoverable collection as part of a scope, and that can easily be browsed and installed using any package manager. And this visibility increases collaboration and improves time to market. So on that note, let's dive into understanding how we can put these principles into practice. With that understanding, let's turn our attention to our demo, Chatterbox Labs, an innovative tech company renowned for their AI chat product. At the heart of this operation is a chat worker, a fine-tuned piece of functionality that employs serverless to generate engaging human-like responses. The Chatterbox team sought to add new features to their AI chat product. The Chatterbox Lab itself is composed of two teams, the AI chat team and the infrastructure team. The AI chat team built on the end user product. The infrastructure builds the core infrastructure to power the products. As they were scaling to add more features, they realized that they were getting overshadowed by the complexity of adding these new edge functions. And this is where it enters Bit. This is Chatterbox Labs' chat component. It gets powered by their chat worker and lets you communicate with GPT to ask any question. So we will start with asking, what are cloud functions? You can see it takes an input. It will forward it to the chat worker, wait for a response, and then let us know. It also keeps track of the session with ChatGPT. So I can ask me what was the last question I asked. And it knows what last question I asked. So the heart of this chat is a composable chat worker. And I will show how a composable chat worker looks like. A composable chat worker is a lightweight worker that composes a chat handler along with all the cool infrastructure components built by the infrastructure team, the GPT session manager, the GPT client, the session manager itself, and the request handler. All of these are independent components that are versioned and deployed separately and are composed together to build a chat worker. In Bit's world, everything is a component, including an app. An application is a special type of component that is deployable, and our worker is an app type. I will move on to the code. This is our local workspace, and this is where all our components are currently residing in. As you can see, I have a chat worker, a chat handler, and the infrastructure components for it. We will move on to the code, and let's look at how this chat worker looks like. As we said, a worker component is an app component. So there are two key things for it: an application root that knows where the application to deploy from, and a CF worker file that contains all the deployment options on how to deploy this worker. If I go back to the app root, you will see that it's lightweight, and all it does is it composes different components together and adds it to the fetch interceptor. At the end, all it is a request handler with a chat handler and a session manager. Our infrastructure team has worked hard to abstract away everything that's related to managing the session. In this architecture, let's say we have a bug on how requests gets handled and we weren't handling CORS correctly. So let's see. Let's update this. In a non-composable way, it's really difficult to understand the dependence of this. Who are using request handler? If I do change request handler, what needs to be updated? But with Bit, it's as easy as doing a Bit status. Bit has this dependency graph with complete knowledge of all dependents. It noticed that I changed the request handler. It knows what two other workers that depend on it. As soon as I snap or tag, they will get deployed. Let's see how easily we can add a new worker using composition and modularity. So as we have discussed, a worker is a composition of a handler and a request and a session manager. And this is what we will do. We will create a worker that helps to translate. So what we are doing with this command is we are creating a translation worker, which uses the node N. It lives in the Cloudflare worker namespace on the scope owned by the Chatterbox Lab organization under the AI chat. And after that, we will create a translation handler, which is also a node component, lives in the handler's namespace and in the AI chat. So Bit will scaffold these two components, and we will start with the handler, because we know the worker just composes the handler at the end. So we will go to the translation handler, and we see Bit has created a main file, a test file, a file for documentation, a file for compositions, and the root index file. So let's update the translation handler. The best part is with composability that we can do copy and we can do paste. And all it is, the translation handler needs to describe what kind of request data it accepts. So in our case, translation handler request data, it will take a session ID and a target language. And if there is no target language, we will just throw errors saying missing target language. Let's extract target language from here. Let's rename this translation handler. And the best part is our infrastructure team, decoupled from us, unblocked, working hard on their scope, has already updated the session manager to support translation. So all we have to do is translations equals session manager. Nature.translate. It will take a target language. It will take a session ID message, and we will relay this information back. And that's it. With that, just changing the request data, updating how we used our reusable session manager. We have created a complete translation handler. Let's add some tests. To make life easy, I have already written some tests I'm going to paste, but what I'm going to show is the power of composability while writing tests as well. Already looking ahead, knowing that we will be composing this, I provided us mocks as part of their component, which makes writing tests effortless because now we can compose tests using these mocks easily. So we know the translation handler has a dependency on the GPT client. We have a GPT client mock. So we also have a mock for the session manager, which we don't have to manage. And we write our test to make sure, given the right input, it produces the right output. And the way we have composed this, the translation handler is completely agnostic to the execution environment, which is key. You can use this anywhere, whether it's in a worker environment or a node-based microservice. All it is a simple function. Given a specific input, it will give you an output. For now, for compositions, we will just remove it, but we can add more compositions to explain the usage of our translation handler. So let's go back and let's build our translation handler, and it will run all the tests. We can see there is a GPT error it throws because of a mock rejected value. We can fix it and we will deploy it. Before we move forward, let's show you the translation worker. The translation worker, like we discussed, being an app type, needs an app root and a CS worker file. It's translation worker will need an app root and we'll need a CF worker file that describes the deployment object. And then we do our favorite part. We go back, give it right, take this, and we paste it back. Everything looks same. This is our translation worker app. We will rename our worker. And we will update our routes for it. Late. And what we need is to make sure we have our Wrangler file for any local configuration. This includes any env environment variables. We don't need any tests because our components are testing it for now. That compose this, we can update our compositions for now to make sure it passes. Docs look good. Index file has been updated. And for now, we will go back to our translation handler. Get this working. So with that, we have a translation worker working. Since the translation worker is an app type, it requires the Cloudflare worker to exist in your workspace, so it knows how to handle the app type. We can do bit use, team bit cloud provider aspect. It will update your workspace JSON-C with the Cloudflare worker. In our case, it already exists, so it will say that it's already configured. Once that's configured, it knows how to run these apps. Then all we have to do is compile. And we can run the translation work. So we also have to register the translation worker since it's an app. So what we will do is we will add the translation worker to our workspace JSON. And then we just run the translation. We can run locally to see how it works. And then all it takes for us is to snap or tag the component to deploy it. The deploy pipeline will automatically read the deploy options from the CS worker file and deploy it. So in my case, I can snap in case you're not sure that this change is production ready, tag if you're sure this change is production ready. Give it the sort ID, deploy test. While this deploys, I will take back to the Bit UI and we will start exploring the discoverability part of it. So unlike the traditional mono multi-repo where this code is either living in a single giant mono repo or multiple repositories, in Bit, everything is hosted in scopes and it's a discoverable collection. So for Chatterbox Lab, we have two scopes, the AI chat and the infrastructure. You can see for someone reviewing, trying to explore this, there's full documentation available that explains how this will be used. There are previews that shows how to use the component. Test results show what tests have been run. There is an API reference tab that will extract all the API from the code itself. So you don't have to jump into the code to understand how to interact with it and how to use it. It will extract classes, their APIs, and you have access to the code, the change log that will show you every change with the version. So it's easy for you to check out and redeploy to a specific version. So this is all the benefits you get from Bit as it becomes a discoverable collection. Looks like Cloudflare is having some internal issues for deployment. Excellent timing. But the idea is as soon as you snap, we have a deploy task. And if Cloudflare is working fine, it will deploy. And you will see on your dashboard that the deployment has gone through and it's been successful. With this makes the whole process seamless. End to end, I have individual functions that are independently versions. I change a function. There is clarity in knowing what will be the impact of this change, what needs to be tagged. There are fine-grained version control. So I can go back and redeploy a specific version, being confident knowing what change will be deployed. And with the power of composability, like we saw, it was easy for us to compose these workers with the existing components and deploy them. And with Bit, each function is now part of a well-structured symphony, each playing its part in harmony and delivering your application's functionality. The ability to independently componentize these components. Without Bit, think about how would you approach this? Would you have a Git back repository with manually managing core components and publishing to NPM? And then how do you track dependencies of what's using what version? So at the end, what Bit does, it provides a complete platform to manage the distributed functions, not only the dependency handling from tagging to deployment to be able to explore it when you deploy to Bit Cloud, extracting the schema for it, running tests. It's an end-to-end system to be able to build these components independently.